Good morning, students. Today we are going to discuss about the stick diagram, design rules, and layout. So the design rules are: it is a set of design rules which allows to translation of a circuit into actual geometry in silicon. The circuit design will be converted into geometrical form in the silicon. Usually, this circuit will be in stick diagram or symbolic form, and it is the interface between the circuit or system designer and the fabrication engineer. So it interfaces the circuit designer or system designer and the fabrication engineer, and it governs the individual layout of the components and the interactions, spacings, and the electrical connection between those components. And there will be a two issues in the design rules. One is the geometrical reproduction of the feature that can be reproduced by the mask making and the lithographical process. And then another one is the interaction between the different layers. So the rules are two different type of rules. One is the micron based rule, and then another one is the lambda based design rules. So let us discuss about one by one. In the micron based rules, it is the it have some it will be stated by some micron resolution, and it is normally used for industries. And then in the lambda based design rules, it is popularized by Med and Conway, and every the single parameter will be configured by the lambda, and it will be used for the educational context and in the design of multiple project chips. So the lambda based design rules are based on the Med and Conway works, and all the paths in layers will be dimensioned in lambda units, and the subsequently lambda can be allocated an appropriate value and compatible with the future size. For example, if the value is 1 micrometer, so the future size on the chip will be 2 micrometer. So the in this specifies the line with the separation and extensions are all will be in the lambda, and the three different approaches for contact making contacts between polysilicon and diffusion. The one is polysilicon to metal, and then metal to diffusion. So here the metal will be in blue color, diffusion in green color, and the polysilicon in red color. The first thing, polysilicon to metal, and then metal to diffusion. This is one way to implement the uh, making contacts. And then another one is buried contact. Buried contact means um, polysilicon to diffusion. Polysilicon to diffusion. The dotted line, that is the buried contact. In that, every the length and the width of the buried contact will be specified in the lambda. And then butting contact, the butting contact will be polysilicon to diffusion using metal. So the next thing is double metal process rules. In the double metal process rules, the two layers of metal will be um, deposited. So each layer, the second layer will be relatively greater than the thickness of the first layer. So between the two layers, to distinguish the contacts between first and the second metal layer, the layer is called as via. And then second metal layer representation is color coded as dark blue or the purple. So the oxide layer will be deposited by the atmospherical chemical vapor deposition between the by to depositing the oxide between the first layer and the second layer of the metal. Depending upon the process, removal of selected areas of the oxide is accomplished by plasma etching. And then next is CMOS lambda based design rule. This is the extending of the Med and Conway concepts. Rules are also concerned with those features unique to P-well CMOS such as P-well and P plus mask and the special substrate contacts. Although CMOS rules in the total may seem difficult to comprehend for the new designer. Once use has been designed of the simpler NMOS rules, the transition to CMOS is not harder to achieve. So in this video, we discuss about the design rules and the layout, uh, micron based design rule and then lambda based design rule and then double metal process rules and then CMOS lambda based rules. Thank you.